The North American 10-15 was one of the most ambitious and groundbreaking aerospace projects of the 20th century, a rocket-powered experimental aircraft jointly developed by NASA, the United States Air Force, and North American aviation during the height of the Cold War and the space race, designed not merely as a fast plane but as a flying laboratory that pushed the boundaries of speed, altitude, materials science, and human endurance in ways no previous aircraft had attempted, making it a bridge between atmospheric aviation and true spaceflight. Built to explore regimes of flight beyond the capabilities of jet-powered aircraft, the X-15 program ran from 1959 to 1968 and remains famous for producing the fastest manned aircraft ever flown within the atmosphere, reaching a maximum recorded speed of Mach 6.7, 7,273 km per hour, 4,520 miles per hour, and a maximum altitude of 107.8 km, 354,200 feet, which allowed several of its pilots to qualify as astronauts under both U.S. Air Force and international standards. Since the Kármán line, the internationally recognized boundary of space, lies at 100 kilometers. In terms of design, the X-15 was a striking departure from conventional aircraft. It was relatively small at only about 50 feet long with a wingspan of just 22 feet, but its fuselage was extremely robust, made of Inconel X, a nickel-chromium-based superalloy selected because it could withstand the skin temperatures of more than 650 degrees Celsius, 1,200 degrees Fahrenheit, generated by aerodynamic heating at hypersonic speeds, temperatures that would have destroyed aluminum, the standard aircraft material of the time. The aircraft's distinctive wedge-shaped vertical stabilizers and short, stubby wings were chosen to provide stability at extreme altitudes where the air was thin, while its cockpit was pressure-sealed to protect the pilot from near-space conditions. Unlike traditional airplanes, the X-15 was not capable of taking off from the ground under its own power. Instead, it was carried aloft by a modified B-52 Stratofortress bomber to about 45,000 feet, then released like a parasite aircraft, at which point its single Thiokol XLR-99 rocket engine, fueled by liquid oxygen and anhydrous ammonia, could be ignited to propel it rapidly upward and forward with 57,000 pounds of thrust, enabling test profiles that pushed the edge of human and technological limits. Once its fuel, which lasted barely 90 seconds at full power, was exhausted, the X-15 would coast upward or along its trajectory before gliding back to Earth, landing on its unpowered stubby wings and skids on a dry lakebed runway, in a manner later echoed by the Space Shuttle orbiter, which clearly drew inspiration from the X-15 program. Across 199 flights conducted by 3 different airframes, the program tested countless aspects of hypersonic flight including aerodynamic heating, structural loads, stability and control at extreme altitudes, physiological effects on pilots, the behavior of materials and instruments in near space, and the transition between atmospheric flight and ballistic trajectories. The X-15 was not just a machine, it was a program that involved some of the most legendary test pilots in aviation history, including Neil Armstrong, who later became the first human to walk on the moon, Joe Engle, who went on to command the Space Shuttle, Scott Crossfield, who was the first man to fly at Mach 2 and Mach 3 and piloted the first X-15 flight, Robert White, who became the first pilot to exceed Mach 4, Mach 5, and Mach 6 in the X-15, and Pete Knight, who set the maximum speed record of Mach 6.7 in October 1967. In total, 12 pilots flew the X-15, and 8 of them were later awarded astronaut wings due to flights exceeding 50 miles 80 kilometers altitude. The data gathered was immense, thousands of technical measurements of heat flux, control response, structural strain, and human performance under extreme acceleration, all of which fed directly into NASA's designs for the Apollo spacecraft, high-speed re-entry vehicles, and ultimately the Space Shuttle. But the program was not without tragedy. On November 15, 1967, during Flight 191, pilot Michael J. Adams lost his life when his X-15 entered a spin at hypersonic speed and broke apart during re-entry, making him the only pilot to die during the program, though his sacrifice further highlighted the inherent risks of exploring uncharted flight regimes. The X-15's unique hybrid role, part aircraft, part spacecraft, made it a symbol of Cold War-era technological daring, serving not only as a research vehicle but also as a demonstration of American aerospace supremacy at a time when the Soviet Union had shocked the world with Sputnik 1957 and Yuri Gagarin's first human spaceflight 1961. While its flights were suborbital and brief, the X-15 showed that a manned craft could survive the harsh aerodynamic and thermal stresses of hypersonic flight, could gather useful data above the atmosphere, and could be guided back for a controlled landing, all of which were essential stepping stones toward reusable spaceplanes. Its legacy is massive. Modern hypersonic aircraft projects, scramjet research, high-speed missile technology, and even contemporary concepts for spaceplanes and vehicles like the X-37B and future NASA hypersonic demonstrators trace part of their lineage to the X-15's experiments. Even the Apollo Command Module's heat shield design benefited from lessons learned about high-temperature re-entry gathered from X-15 missions. In the end, the program lasted nearly a decade, consumed millions of dollars, and tested 3 built aircraft, 2 of which survive today in museums, one at the Smithsonian's National Air and Space Museum in Washington, D.C., and one at the U.S. Air Force Museum in Dayton, Ohio. But its return on investment in terms of scientific data, aerospace engineering breakthroughs, and pilot experience was incalculable. Though its airframes are now museum pieces, the X-15 continues to stand as a monument to human courage, scientific ambition, and engineering genius, forever remembered as the machine that took us faster and higher than any aircraft before or since, bridging the gap between airplane and spacecraft, and proving that the dream of spaceflight was not only possible but achievable through bold experimentation and relentless pursuit of the unknown.